On to working with proportionality problems. If this doubles, what does that do? This is the important stuff. Analyzing relationships is far more important than being able to look at an equation and plug in numbers and press a button on your calculator. It does not take an understanding of physics to do that. So instead, we're going to use proportionalities to see what the relationships are and how they change. That is a lot more useful and important to understand. A proportionality problem is a problem where you are not given a specific number for distance or velocity or acceleration or time, but instead you're given a scale factor, what the quantity gets multiplied by. Examples of this sound like an airplane requires 250-meter runway to accelerate to takeoff speed. If the airplane needed to take 4 times as much time to reach takeoff speed, how long must the runway be? If a car needs to go from rest to speed v, it takes distance d. How far must the car travel to reach speed 3v? A car requires the distance to stop. How far will the car take to stop if the car travels twice the speed? And finally, an object takes 10 seconds to fall from the top of a building to the bottom. How much time would it take to fall from a building 3 times as tall? We're going to solve any proportionality problem in the same way using guess. The only difference is scale factor are the givens. We ignore coefficients because coefficients don't change even as the distance, time, or velocity is scaled. Watch it as it happens in the next 4 examples. All right. An airplane requires 250-meter runway to accelerate to takeoff speed. If the airplane needed to take 4 times as much time to reach takeoff speed, how long must the runway be? A, so the acceleration is staying the same. T is t times 4, and x is 250 meters. So we're looking for x times. So we're going to use the relationship that has x, t, and a in it, which is x equals 1/2 at squared. We're starting from rest, so it's a simplified equation, and this equation has distance, acceleration, and time. Substituting in, we're looking for this. We know that the coefficient here, this is the coefficient, the number leading, isn't going to change anything, so we can just remove it, ignore it. Acceleration is 1 times the normal acceleration, and time is 4 times the normal time. So, remember, 4 is squared. 4 times 4 is 16, times 1 is 16. So x will be 16 times as long. 250 times 16 gives us 4,000 meters. Get the idea? I hope so. Try this one. Car needs to go from rest to speed v if it takes a distance d. How far must the car travel to reach a speed 3v? Acceleration is the same. We've got a rest in there. V, we're looking for how far, so we're looking for x, or the distance, d, sorry, not x. If the problem gives us a variable, then we better use that variable. So this could be lowercase d, it could be capital D, it could be x, it could be y, it could be capital X, it could be capital Y, it could be anything, and it really doesn't matter as long as you know and the person reading your problem knows that that is the variable you are using. So if a problem gives you a specific variable that is not normally what you would use, please use that specific variable. V squared equals 2AD because A, V, D, no time. So we use the no time equation. Start from rest. So the simple equation, this is the equation, acceleration. Velocity is multiplied by 3 times, but remember it's velocity squared, so we got to square that 3, equals the 2 we don't care about, 1 times our acceleration, and the distance we don't know. So d equal times 9, because 3 times 3 is 9. So the new distance is 9 times the initial distance. Example 14. A car requires a distance d to stop. How far will the car take to stop if it travels twice the speed? Acceleration is the same. Velocity is twice the distance because it's how far will the car take. No time equation, starting from rest, so we're simplified. Substituting in, velocity is doubled, and then squared equals times 1 for the acceleration. 2 doesn't matter, and we're looking for d. So we get 4. D times 4. So the new distance is 4 times the initial distance. An object takes 10 seconds to fall from the top of a building to the bottom. How much time would it take to fall from a building 3 times as tall? Pause it. Try this for yourself, please. Acceleration is the same. Distance is 3 times. T is 10 seconds. So we have axt. X equals 1/2 at squared, starting from rest. So we can be... How do I know we're starting from rest? There's nothing on there that tells me we're starting from rest. Other than it says we're falling from the top of a building. Think about it. If you are standing on a building and you go backwards and you fall, well, you go backwards this way until you fall. As soon as you start falling in the downward direction, you don't have any starting speed going down, right? Nobody's throwing you down. You just tripped and you fell off a very small building, a playhouse perhaps. 3 times is the x equals 1 times, and we don't know, squared. Remember, coefficient we don't care about. T squared. Where would you mess up on this problem? You would forget to square that t. So d times the square root of 3, because the new number you must square to get 3. So the new amount of time is 10 square root 3 seconds, or about 17 seconds. Because of that square. Remember, we're not looking for square, we're not looking for t times squared, we're looking for just t times. The end. Work out that last one. Make sure you can do that one before doing your exit ticket for sure.